Hello Year 11s, I hope you're all well. Welcome to another maths lesson. As you can see on the screen, I have displayed the Edexcel Higher checklist. I'm just going to go through it again. I haven't gone through it for a few weeks, just to update you guys on some of the topics which we have covered. Of course, I talk about this checklist a lot. Please make sure you are constantly updating your own checklist. For example, iteration, a topic which we've covered recently, and we did quite a lot of practice on it. Well, I say a lot of practice. We had a lesson and a whole Sparks task dedicated to iteration. If, for example, you still struggle with iteration, practice exam questions, feel free to ask me for help, and then eventually, hopefully, you'll understand it really well, and then you can tick it off. Of course, we've done some work on proof. We haven't done this one yet, but we will do soon. We done geometric sequences, so geometric progression, geometric sequences which have a common ratio, of course. We have done some work on graphs of exponentials, real life exponential graphs. I gave you guys a few good examples, I think, of real life exponentials. Translations and reflections, we did that last lesson. And of course, we've done some more practice on turning points, quadratic sequences. There's a few which I will be highlighting in green after I finish this video. Of course, we haven't done circle theorems or vectors yet, but we've done a bit more practice on trig. We could do more, but please make sure you're practicing as well at home. So polygons, we've done some practice on polygons. I included plans and elevations on a Sparks homework as well. And I mean, alternate and corresponding angles, it's one of those where you guys have done it a lot of times, but there's so many different types of questions which can come up, so you have to be ready. In terms of remote learning, we've covered all of stats and all of probability, so please make sure you're constantly going over your notes. It's very easy to forget little things, so please make sure, like for example, stratified sampling. It's not the hardest concept in the world to understand, so as long as you remember what you did in that lesson, you should be okay on those types of questions. It's the same with working out quartiles, interquartile range, and so on and so forth. For probability, conditional probability looks like it is the hardest, and again, please make sure you check out those TikTok videos I created and uploaded on Friday night. They will help you if you have any misconceptions regarding conditional probability. Algebraic probability, I want to revisit that at some point in the future as well. We'll be doing it for some starters, hopefully, in the future. Coming onto this page, there's not much here, I don't think. We've done some work on compound interest, simple interest, growth and decay, which is here. So I'll tick this off. Interpreting proportion, we've done that. Percentage change as well. So we have done quite a lot. Simple interest and financial maths is here. And express one quantity as a percentage of another. So we have done some percentages. Of course, we will do more as well in the future. But please make sure you're updating your checklist as well. I would like you guys to be at a similar stage to me in a sense that you haven't covered everything. You won't have a perfect knowledge of everything. But as long as you are confident on most topics, then I'm hopeful that you should be doing well in for your final GCSEs. I just noticed recurring decimals as well. We've covered that, and I'm pretty sure I did a TikTok video on it as well. So that's another thing. I've done so many TikTok videos now that I've covered probably 7 or 8 different topics. So please make sure you check those out as well in your spare time. I'm now going to move on and get started with our lesson for today. So the title of the lesson is Trigonometry Graphs. And before I show you the starter activity, well, I've already talked about recap, but I'm going to talk about these other things. So if you have any overdue remote learning assignments, please make sure you complete them as soon as possible. And more importantly, please make sure you are doing all of your Sparks tasks. There are a lot of overdue tasks, so please make sure you're doing those as soon as possible. It says here, look, using Sparks for 4 hours per week on average increases a grade by 1 GCSE grade. 4 hours per week. Just ask yourself the question, am I spending significant amount of time on there to actually make progress, or am I just going on there 10 minutes, 15 minutes, 20 minutes and then giving up and logging out? Just think about that carefully. And of course, look, I'm here to help you guys. Please make sure you reach out to me if you need help. And yeah, just make sure you're just doing as much as you can to make progress, really. Here is the starter activity. It's a transforming curves exam question, 2-mark exam question, and it has 2 parts. So let's just say question 1, part A and part B. So go ahead and pause this video and have a go at answering the question. I'll go through the answers in a sec. So we can see the graph of y equals f of x, and we have to use it to determine the transformation taking place to map y equals f of x to this A curve and this B curve. So let's start off with part A. We can see that the shape is the same. It hasn't moved up or down, so the y values will stay the same. So I'm actually going to make a note of this here. Y values stay the same. I'll just write y same. So it has to be a transformation which affects the x values, and it's pretty clear that it's being shifted 3 places to the left. So remember, if we shift to the left, we are using a transformation of this form, and I'll also write translation with vector -3. Sorry, that is -3, 0. This is really important. Whenever you're shifting to the more negative side, it's going to be x plus 3. And if you're shifting to this side, it's going to be f of x. For example, take away 3 or take away 4 or whatever. So it's always the opposite. It's quite weird in that sense. Now let's look at the second part of this question. So firstly, let me just change the color actually. So firstly, I can see a reflection taking place. But let's say we reflect about the x-axis. Then our graph will look something like this. So this is a reflection in the x-axis. We can see that if we compare this blue curve to the original here, we can see that the x values are the same. So x is the same. The transformation is going to be, the negative sign is going to be outside the brackets. So it's going to be here. So it's negative f of x. So negative f of x. And now we're shifting it 1 place downwards. So, alright, negative f of x, take away 1. Negative f of x is... So this is a combined transformation. There are 2 transformations taking place. First, a reflection, followed by a translation. So I'll write here reflection in x-axis followed by translation 0, 1, 0, -1, and yeah, that would give you 4 marks on this question. Please, please, please let me know if you don't understand this topic. I'll go through it with you individually, but just don't leave it and just pretend, I don't know, eventually it's going to work out, because I need to help you if you are having difficulties with this topic and with all the other topics. So here we can see a nice little breakdown, which I showed you guys last week as well, of the different type of transformations which you guys will need to know about. Today's lesson is, of course, on trigonometry, and so I'm showing you guys this sheet of paper which you've looked at before. You all should have a copy of this. I'm just going to talk about it very briefly. So we have Pythagoras' theorem. Of course, that does appear in a lot of problem-solving questions. SOHCAHTOA, of course, is a very basic concept of trig. Always remember that you can only use Pythagoras and SOHCAHTOA when it is a right angle triangle. The same goes for this area, half base times height. It has to be a right angle triangle. As for non-right angle triangles, you use sine rule, cosine rule, and a different formula for the area of a triangle. And of course, remember a few months ago we did proofs for all 3 of these. Please make sure you're going over your proofs as well, because there may be a question on the exam which asks you to prove one of these 3 rules or equations, whatever you want to call them. So yeah, just bear this in mind. Non-right angle triangles, you use sine rule, cosine rule, or area of a triangle if you want to work it out. And Pythagoras, SOHCAHTOA, and this area of a triangle just relates to right angle triangles. Here we have an A-level exam question. Now, you might be thinking, why are you showing me an A-level exam question? But the reality is that this question can be answered with GCSE knowledge. It's just a much harder question because there's a lot of information. It's clearly a problem-solving question. You have to think very carefully, use the information in the question. 2 paragraphs, so it does make it harder for the student to answer the question. But I'm gonna revisit this later, and hopefully using some hints provided by myself, you will be able to answer this question. Once again, a lot of questions towards this end of a paper or second half of the exam paper are very difficult, grade 8, grade 9 questions, and they're very similar to this one. They'll give you a lot of information, try to confuse you, but what are we going to do? We're going to highlight the key information, then we're going to annotate the diagram, and then we're going to answer the question and get 6 marks. So we'll do that later. But now we're going to revisit trig graphs. So last week I asked you to sketch the cosine graph and the sine graph as well. So hopefully by now you are able to do that. As I said, the way I remember it is that cosine 0 is 1, so the cosine graph starts at 1, whereas sine 0 is 0, so the sine graph starts at 0. Now we're going to learn how to use the trig graphs to work out particular values. So here it says approximately, what is the value of sine 40? Let me just change the color of my pen. Sine 40, so x equals 40, y equals sine 40. So sine 40 corresponds to this value here, which the scales aren't great, but I'd guess this is around 0.65. So alright, sine 40 degrees equals 0.65. Are there any other angles that have the same sine value? In other words, are there any other values which also give you an answer of 0.65? Well, yes, there are. If I were to extend this line, I can see there is another sine value here. Another sine value which corresponds to 0.65. I will draw this line down and I can see sine 140 is approximately 0.65. Notice there's a bit of a pattern here. 0 or 180, 10, so sine 10 is the same as sine 170. Sine 20 is the same as sine 160. Sine 30 is the same as sine 150, and so on and so forth. So in terms of generalizations, we could write something like this. So let me just write this first, and then I'll write the generalization. So in terms of a generalization, we could write sine x equals sine 180 take away x, because we can clearly see a pattern emerging there. So yeah, moving on to tan. Okay, we talked about tan last week, about the asymptotes as well. One thing I want to add is regarding cosine graphs and sine graphs, I want to introduce a few keywords. So the first one is periods or periodic. They are both periodic, and I said this last week. Again, I want to repeat it because it's an important word for you. It's important for you guys to know what this word means. Here the cosine graph starts at 1, and here it's back at 1. So it goes down, gets to -1, that's its minimum value. Then it goes back up to 1, then it repeats again. So a function which is constantly repeating is a periodic function. And each period, in this case, each period is 360 degrees. So right here, periods of 360 degrees. Let's just investigate the graph of sine x. It starts here, and it increases, gets to 1, decreases again, gets to 0. So you could say, oh, the period might be 180 degrees. However, it decreases again, and it gets to -1. And then it gets back up to 0, and now it is then going to increase, get to 1 again, then it's going to decrease, get to -1. So one period for the sine graph is also 360 degrees. And so the sine graph is also a periodic function. And yeah, so another keyword I want to mention is amplitude. So where should I write this? I'll write amplitude here. Amplitude now. Amplitude means the distance between the minimum and maximum points to the x-axis. So here we can see a distance of 1, and of course here we can see a distance of 1 as well. So y equals cosine x has an amplitude of 1. Y equals sine x has an amplitude of 1 as well. If we were to transform one of them, let's say y equals 2 cosine x. So that would change the graph, and it would look something like this. where this is a 2, this is a negative 2. And so the amplitude, is 2 in this case. So yeah, I just wanted you to understand what, in this case, periods mean and amplitude as well. So just briefly talking about tan x, it has periods of 180 because from this asymptote to this asymptote we have a curve, and that curve will then repeat itself. So periods of 180 degrees, and of course because of the way it's shaped it doesn't have an amplitude. Now I would like you to pause this video and answer the question on the screen. Write down which two angles have the same sine value, then two more angles which have the same cosine value, and two more angles which have the same tan value. So let's start off with sine. Again, I mentioned a number of examples. Let's go here and say that sine 200 is the same, gives us the same y value as 340, so sine 340. There, as you can see, there are so many different possibilities, so I'm sure your example is probably correct as well. Let's just do, let's do this one. Cos 80 is the same as this is looking confusing now, but I'll write it down here. Cos 80 is the same as cos 280. Again, you can clearly see there's a symmetrical line here, so that makes it a lot easier for you to work out these values. Now, as for tan x, let's just pick this one for example. Tan 70 is the same as tan 250. Tan 70 is the same as tan 250. So just by drawing the curves, and I always suggest, I always recommend you guys to draw the sine, cosine and tan graphs in an exam. You can work out values which are the same as one another. Let's take this value here, tan 100. This is the same as this value, which is tan 280. Both angles are 10 degrees higher than where the asymptote is, so you can clearly see there's a pattern emerging here. It's not just random numbers being the same as one another. So here we have a number of exam questions for you guys to do. Pause the video and press play when you're ready to see the answer. So the first question, y equals sine x. So it starts at 0, we know that it peaks at 1, so this is going to be 1. And this is going to be 90. This is going to be 180. Here we have 360. So coordinates of P are 90 degrees and 1. And Q we have 180 degrees and 1. On the grid below, sketch the graph of y equals tan x. Please remember, so yeah, pause this video, have a go answering the question. And yeah, what I was going to say is, please remember the asymptotes are at 90 and 270. The tan graph has periods of 180 degrees. So the asymptotes are every 180 degrees. There will be another one here at negative 90. There will be another one here at 450. So it would go something like this. And we could actually extend it and go like that if you want as well. Properties of trig graph. So match each property to the graph of sine x, cosine x, and tan x. Each property can be used more than once. So once again, please pause this video, have a go at answering the question, and when you're ready to see the answers, then press play again. Before I go through this question, I'm going to say that if you see a similar question in the exam, always draw, or I should say sketch, the graphs of sine x, cosine x, and tangent x. Reason being is it's very easy to make a mistake. It's really easy to get one mixed up with the other. So when you draw it, you're a bit more, you're a bit more comfortable because you can see it there, you can check your answer. So I'd say always sketch the graphs. I'm going to do that now quickly. Oops. Cosine, sine, and tan. Has amplitude 1. I'll write C, S, and T just to make it a bit easier. Let's use blue. So cosine and sine has asymptotes at 90 and 270. Tan, the only one which has a period of 180 is tan. Passes through 0, 0. Now this is where the graph comes in handy. Passes through 0, 0, passes through 0, 0. So I'll write T and S. Passes through 180, 0. So let's see. This is 180, 0. Wait. No, it's not. This is 90. This is 180. Here we have 180, 0. Here we have 180, 0 as well. So passes through 180, 0. T, S. Has period 360 degrees, of course, C and S. And passes through 90, 0. The only one who passes, the only graph which passes through 90, 0 is cosine. Another way of working out trig functions with angles which are larger than 180 degrees is to use the unit circle. Now I'm not going to show you the circle straight away. We're going to break it down, go through it step by step. Here we can see a right angle triangle being drawn, and we can see the hypotenuse is 1, coordinates P, now we don't know what P is as of right now, and an angle of 73 degrees being drawn. So it says here, Marita plots the point P, the length of the green line is 1 unit. How can you use this to find the coordinate of a point P? I think they should say coordinates of point P. So using SOHCAHTOA, as you can see, it's a right angle triangle. Let's label it. So hypotenuse, opposite, adjacent. So right here, sine 73 equals opposite over hypotenuse. Cosine 73 equals opposite over, adjacent over hypotenuse. But if you look at the hypotenuse, is 1, so sine 73 is the same as the opposite, divided by 1, which is just the opposite, and cosine 73 is the same as the adjacent divided by 1. So right here, cosine 73, sine 73. So this triangle has a base of cosine 73 and a height of sine 73. So the coordinates will be cos 73 sine 73. So then by typing that into a calculator, we will be able to work out what cos 73 and sine 73 are. Can we generalize this? So as long as the hypotenuse is 1, then we can say that sine, in this case theta, equals opposite over hypotenuse, in this case opposite over 1, so it's just opposite. I'll write op so it doesn't look like 0. Cos theta equals adjacent over hypotenuse, in this case adjacent over 1. So let's write cos theta here, sine theta here. So write down in terms of theta expressions for the x and y coordinates. So now we can say x, y equals cos theta. So the x coordinate is cos theta, the y coordinate is cosine theta. Another thing we could do is use Pythagoras' theorem to show that cos theta squared plus sine theta squared is 1 squared, which is just 1. So here it now says, what can you work out? So given the diagram on the left, where we've actually been given the exact values as well, so above it I'll actually write cos 73 because it's equal to this decimal, and sine 73 is equal to this second decimal. Given the diagram on the left, what can you work out about the diagram on the right? Can you predict the values of A, B, and Y? Okay, so we can see that we have 2 right angle triangles, one here, one here. The base here is this value, and we can see that given that the x coordinate is this, the base of this triangle is also the positive version of that x coordinate. The height, well, we can see the hypotenuse is 1. They have the same side. They have the same angle here as well, 90 degrees. And so, using Pythagoras' theorem, we'd be able to work out that the height is obviously going to be the same as the height to the other triangle. So these two are the same triangle. Because of this, we are sure that B is 73 degrees. And as B is 73 degrees, A is 180 take away 73 degrees. So 107 degrees. Lastly, we can say that this coordinate is cos 107 and the other one is sine 107 because of this angle here. So we have investigated the first two quadrants. Now we're moving to the third and fourth quadrants. So here we can draw this right angle and say that this is a right angle triangle. The base is 0.292. The hypotenuse is the same, and so we will have the same height. 0.95. What was the rest? 956. 956. Having said that, it is very clear that this y coordinate will be negative. So, alright, y equals negative 0.956. Of course, both coordinates here will be negative. And now let's work out what this angle here is going to be. So, if this is, it's getting quite messy, but if this is 956, this angle will be 73 degrees. So I'll say theta is 180 plus 73, which is 253 degrees. Lastly, I'll write this is cos 253 and this is sine 253. Oh, why did I write that? 253. What can you work out about the coordinates of P when the angle is between 270 degrees and 360 degrees? Well, again, we have the same triangle here. I'm going to put this angle here because opposite it will be the height, which is this. And the base is 0.292. The y coordinate here will also be negative. Sorry, 0.956. Given that this angle is 73 degrees, theta, which is this angle, will be 360 take away 73 degrees, which is 297. Sorry, 287. See, this is why you shouldn't rush things. So yeah, what can you work out? Okay, another thing I'm gonna write here is that this is cos 287 and this is sine 287. Generalizing. So here it says, I know that sine 107 is the same as sine 73. So let's see, where is sine? Yes, that is true. They're both 0.956. What about cos 107 and cos 73? Cos 107, cos 73. So one of them is the negative of the other. It doesn't matter where you put the negative sign, as long as it's on one of those expressions. Can you generalize Wiener's findings for angles between 0 and 180 degrees? So yeah, I could say, so here we need to replace this with theta. So our first generalization is related to sine, and it's going to be sine theta equals, actually I'm going to first write above it, sine 73 equals sine 107. Now I'm going to write sine theta equals sine 180 take away theta. Because if 73 is theta, then 180 take away theta would give you 107. Now for the cosine graphs, sorry, for the cosine values, cos 180 take away theta equals cos theta. Or you could just put the negative on the other one and write cos theta equals negative cos 180 take away theta. So I've had unit circle on every single slide, but you haven't actually seen any circles. So now I'm going to draw the circle, and it's going to go something like this. It's not the best circle. Yeah, something like this. So, yeah, bear in mind, look, this is the point 1, 0. And yeah, okay. In this case, 1 is the radius of the circle. And so the equation of this circle is x squared plus y squared equals 1. And of course, if we have a theta here, then we can say x and y are cos theta and sine theta. So we could even write cos theta squared plus sine theta squared equals 1. What can you say about sine theta and cos theta as P moves around in a circle? So I'd actually want to highlight whether they're positive or negative. So we've already talked about cos theta and sine theta being x and y, and I've even written an equation involving cos theta and sine theta. But let's just investigate them. If the theta value is between 90 and 180, that would give you a negative x value. So I'll write negative, I don't want to write negative x, but I'll just write negative, positive. Negative x value and positive y value if the theta is between 180 and 270, we have negative values for both. And if a theta is in this fourth quadrant, and so it's between 270 degrees and 360 degrees, we have a negative y value and a positive x value. Now we're going to talk about the tan function. So here it says tan theta and gradient. We're going to investigate the link between the two. If we look at this right angle triangle, here is our opposite, here is our adjacent. How do you work out the gradient of this line? You have to do change in y over change in x. So opposite over opposite over adjacent. And as you guys know by now, opposite over adjacent is tan theta. So now I would like you to have a go at answering these questions. What will the gradient of a green line be when theta equals 90 degrees, 270 degrees, 180 degrees, and 360 degrees? Pause this video, and when you're ready to see the answers, then come back to this video. I'll use an orange pen. So when theta is 90 degrees, the line will go like this. So we have a right angle here, and it's actually possible to work out the gradient of this line. Because it's a vertical line, what is the gradient of that? You'd have to say infinity, and it doesn't really exist, does it? And if you type tan 90 into a calculator, you will get an error, because remember 90 degrees is where one of the asymptotes are. So here I'll write, what should I write? Error maybe? It's the same for 270 degrees. Going back to our tan graphs, we know that 90 degrees and 270 degrees are where we have asymptotes. As for 180 degrees, the line will go like this. Oh my god. It's supposed to be a straight line like this. Horizontal line. So the gradient of this type of line is 0. So I'll write m equals 0, m being gradient. And 360 degrees, it would just be a line like, I want to get rid of markings first. So when theta is 360 degrees, it would have gone around, it would have gone around and ended up here. So the line would look like this. And so the gradient would also be 0. Now we're going to explore the gradient and tangent even further. So here it says, what happens to the gradient of a green line as theta goes from 0 to 360 degrees? What happens at 90 degrees? What happens at 180 degrees? Copy and complete the diagram. So I'd like you to have a go at doing this yourself, answering these questions yourself. Of course, this is an extension as well if you get there. So yeah, pause this video and press play in a few seconds to see me going through the answer. Okay, so here we have a green line which is kind of in the middle of nowhere, but let's start off with here. So when we're at 0 degrees, when theta is 0, of course the gradient is 0. If theta is, I don't know, 10 degrees, for example, we can see a gradient, a positive gradient, but it's not very steep. The higher the theta value, the steeper the line will become. So as you can see, the line is getting steeper and steeper until it peaks just before 90, this is when it's at its most steepest. Then at 90 we have an asymptote, so there is no gradient, doesn't exist. Then our gradient becomes negative. Here we can see this line which I've just drawn here is a negative gradient. I'll write NG for negative gradient. Then it is still negative, but it's becoming less negative in a sense that the line is becoming less steep. So when it's less steep, it's still negative, however the value is closer to 0, if that makes sense. And look, this does make sense because look, it's getting closer to 0, and here when theta is 180 degrees, the gradient will be 0. Now let's move on to here where the gradient is positive again, and it's getting more and more positive because it's getting more and more steep. As you can see, each dotted line I'm drawing now is getting more steep. It's steeper than the previous one. So it's getting steeper and steeper until it peaks, and then we have another asymptote. And then we have a very steep line and a negative gradient. And in this quadrant, it's going to be completely exclusively negative gradients, but the line will also be getting less steep, so the gradient will be getting closer to 0. And as it gets closer to 360 degrees, eventually it will hit 0, because tan 360 is equal to 0. I hope this made sense. I hope you were able to see the link between gradient of the unit circle and the tan graph. But if you have any questions, please let me know. Now we're going to revisit exact values. We first learned about exact trigonometric values start of year 10, where I asked you guys to draw these two triangles. And yeah, since then I've asked you guys to practice, and so hopefully you're able to use them now. This is a 2 centimeter equilateral triangle, which will help you work out 60 degrees and 30 degrees values. The other one is a unit square which has been split in half. Split in half. So I'll draw this dotted line to show you that this was originally a unit square. So this is an equilateral triangle. So 30, 30. Using Pythagoras, we have root 3 here, and we could write 1, 1, like that. This is a 1, by the way, just to make it clear. Sine 30 is 1 over 2, root 3 over 2. I'll leave the tans for the end. Sine 60 is root 3 over 2. Now let's come on to this one. Here we have a 1, the hypotenuse is root 2, so we have 1 over root 2 for both. Notice I left tan for the end. Tan is opposite over adjacent, so we have 1 over root 3, root 3 over 1, and 1. We could also write tan 30 degrees equals sine 30 degrees divided by cos 30 degrees, which is of course a half divided by root 3 over 2, which is a half multiplied by 2 over root 3, which is 1 over root 3. And we could do the same thing for all the others. We will get the same answer as long as our calculations are correct. So I guess you saw here that there's two different ways of working out tan, not just using opposite over adjacent, but also doing sine divided by cos. Now we're going to write down the exact values of, okay, well we know cos 45 is 1 over root 2, 1 over root 2, 1 over root 2, and 1. So now try to pause this video and answer these questions. And you're free to use whichever method you prefer between the unit circle and drawing sine and cosine graphs and tan graphs. Please make sure you do one of those methods though. This is a non-calculator practice question. I'm going to draw the unit circle. So here we have cos 45. It's not that much space. Cos 45 sine 45. That is this point here. This point is cos 135 sine 135. We can clearly see that the y value is going to be positive. So sine 135 is positive 1 over root 2. Cos 225. So that means we have to draw a line here. Cos 225 sine 225. Both values will be negative. So cos 225 will be 1 over root 2. Sorry, negative 1 over root 2. And here we have cos 315 sine 315. I remember tan 315 is sine 315 divided by cos 315. And I mean, moreover, we can see that this gradient here is going to be negative. And so tan 315, it's either going to be positive 1 or negative 1, but we can see here it's going to be negative 1. And we could check here just to make sure. Sine 315 is negative. cos 315 is positive, so this equals -1. Here we have some more practice questions for you to do. So again, you could use the sine graph, cosine graph, tan graph, or the unit circle. Is completely up to you. But try to answer these questions. As I said, make sure you do it without a calculator. Don't cheat or anything like that. Pause this video and come back to the video when you're ready to see the answers. So on the previous slide, I used the unit circle. So here I'm going to use the cosine, sine, and tan graphs just to show you both methods. Sine 150 degrees will be, so if this is 180, this is sine 150. It's clearly going to be the same as sine 30. So we can work out sine 30 using the triangle, and we did so on the previous slide. So sine 30 is a half. This is a half as well. Cos 120, so this is 180. This is 120 would be here. So that's going to be the same. Well, that will be the negative version of cos 60. So, alright, cos negative equals negative cos 60. Which I believe is also a half. Yes, negative a half. So now we're going to move on to the tan graph. This is 180, so 210 somewhere here. That will be 210 equal 80 is 30, so it will be the same as tan 30. $240 will be here, so tan 40 will be the same as tan 60. It's all about spoiling. Where it's going up by cos 330. Let me use a different color because there's a lot of green here. Okay, cos 330, so this is 360 and this is 0. Cos 330, 330 is here, 30 is here. So these two will share the same value, cos 330 and cos 30, that is. And lastly, we have sine 300. So my sine graph isn't the best. Because this should correspond to 270. But anyways, 300, it's 30 away from the minimum. So it would be a negative value. And what is 30 away from the maximum? Sine 60. So sine 60 is a positive value. Sine 300 is the negative version of sine 60. Now I would like you to match up pairs of equal sine values. pause this video, and when you're ready to see the answers, press play again. Here are the answers. So the way I matched them up is I assigned a letter to one here, for example, and I matched it up to this one. Then I continued going on and on. So the way I worked it out was by plotting a sine graph and, sorry, I'm going to use blue to show you what I did. So I plotted the sine graph. This is sine 22. And when I plotted sine 158, I saw that they're the same. And I did that for all the others. So this is sine negative 10. Sine negative 10 is the same as sine 190. Sine 200, which is here, is the same as sine 340, so on and so forth. The final slide is this one where you have to fill in the blanks. So what cos value is equivalent to cos 55? Pause this video, have a go at answering the questions. So what I did here is I drew the unit square here, and cos 55 is going to be in this first quadrant here, and it's going to give us a positive x value. The only time when cos is also positive is when it is between 270 degrees. Sorry, the only other time when cos theta is positive is between 270 degrees and 360 degrees. So I knew that cos 35 is the same as cos 305, because cos 0 plus 55 has to be equal to cos 360 take away 55. So one cool pattern you can see here is that 55 add 305 is 360, this plus this is 360, and this value added to this value is also 360. The last one, or I should say the third one, is slightly different. Cos 155 will be, let's pick something we haven't used before. So cos 155 will be here. It will give us a negative value, and so it will be equal to a value in this quadrant. So 155, I'll do it like this. I'll write cos, let's say 90 plus 65. That has to be equal to this 270 take away 65. So I'll write cos 270 take away 65. So 205. Here you can see the answers to the tan questions. Now, I've just noticed that my tan graph isn't actually straight, so that's quite annoying, but you can see that tan 44, which is here, is going to be the same as tan, and I'll write it like this, 180 plus 44. Tan negative 20 is here, and it's going to be the same as tan 180 take away 20, which is tan 160. Tan 120 is going to be here. The way I did this is by writing it like this, 90 plus 30, so 90 is here, where the asymptote is, equals tan negative 90, so this asymptote, plus 30. So that gives us 120 and negative 60. The last question is an extension, so I'm not going to bother going over the answer right now, but if you answered that question and want to know or want me to check your answer, then please reach out to me, email me, and I'll be able to help you with that question. Thank you very much for listening, all of you. I know today's lesson was a bit more tricky than usual, but I hope you benefited. And if there is anything which didn't make sense, please make sure you reach out to me either through the chat or by email. It's really important for you guys to learn in lessons, so I'll do my best to try to help you in any way which I can. So yeah, thank you very much, and enjoy the rest of your day. Take care, everyone. Stay safe.